Okay, magandang buhay. Kape muna tayo. Coffee! Ang topic natin sa panglimang vlog ay ang typical home air conditioning operation. Ito yung mga aircon nyo sa bahay kung paano siya nag-ooperate. So, bago tayo magsimula, magpapasalamat muna tayo sa mga nanonood, sa mga manonood. Welcome to my vlog. Pasalamat tayo sa mga nanonood, sino man kayo, sa mga kamaster natin dyan, sa mga kaklase natin, sa mga propesor. Maraming salamat sa inyo, sa mga tinuro inyo sa amin. Sa mga eskwelahan namin, TUP, tsaka TIP, maraming salamat. At kung sino hindi pa naka-subscribe o naka-follow sa aming page, mag-follow na kayo at please subscribe to my YouTube channel. Gagawa pa tayo ng mga maraming vlog para marami tayong matutunan at mag-improve ang ating mga skills at mga talent. Puro theory pa muna tayo ngayon. Sa susunod na yung mga actual. Mapakita ko sa inyo paano mga actual. So, naulit ko, maraming salamat po sa inyong lahat. Let's start the ball for rolling. Okay, papaliwanag ko ang comfort cooling.
Thermal comfort refers to the condition where an individual is satisfied with their thermal environment. It can also be referred to as the neutral condition, as that's when the temperature is just right and you're feeling neither too cold nor too hot.
Comfort cooling muna tayo para kung ano yung komportable sa pakiramdam ng isang human being. Parameters ng comfort cooling. Sa comfort cooling, meron tayo dito sa left side viewpoint. Meron tayong how it feels sa less than 55 degrees Fahrenheit or 13 degrees Celsius. Dry siya, dry. 56 to 60 or 13.3 to 15.6 degrees Celsius. Yan yung comfortable. Yan yung dew point na comfortable. Sa 61 to 64 degrees Fahrenheit, rather humid siya. 65 to 69, humid. 70 to 75, very humid. 75, 75 or 24 above is oppressive na siya, oppressive. So, ang comfort cooling ay merong dry bulb temperature 71 to 80 degrees Fahrenheit. Yan yung parameters niya. Ang relative humidity niya ay 40 to 60 degrees, ay 60%. So, meron din kinalaman yung hangin. Dapat yung hangin na tumatama sa atin ay nasa 15 meters per minute o 50 feet per minute. Pag naramdaman nyo, di ba, pag malakas yung hangin, hindi siya masyado. Hindi ka komportable. Pag mahina naman, hindi rin. Comfort velocity. Velocity. No? Siyempre, hindi mawala dyan yung kalinisan, cleanliness. Cleanliness ng hangin. Kaya nga naman, pag may utot ang hangin, siyempre, hindi ka komportable doon. Uli kaya pollution. O, ito yung odor. Odor pala yun. Odor. Mga amoy. Tapos yung noise. Radiation effect. Okay. Yan lang yung mga parameters. Comfort, cooling.
A typical home air conditioning system operating at a design temperature of 24 degrees Celsius inside temperature has a relative humidity, moisture content of the conditioned room air, of 50%. The air in the house gives up heat to the refrigerant. The indoor coil is also responsible for removing some moisture from the air to keep the humidity at an acceptable level. This is known as dehumidifying. At point 1, 72% liquid and 28% vapor leaves the metering device and enters the evaporator. At point 2, the mixture is saturated R410A at a pressure of 120.6 psig, which corresponds to a 5 degrees Celsius boiling point. It is important to remember that the pressure is 120.6 psig because the evaporating refrigerant is boiling at 5 degrees Celsius. At point 3, the mixture tumbles through the tube in the evaporator with the liquid evaporating from the 24 degrees Celsius heat and humidity load of the inside air as it moves along. At point 4, when the mixture is about halfway through the coil, the refrigerant is composed of about 50% liquid and 50% vapor and is still at the same temperature and pressure because a change of state is taking place. At point 5, the refrigerant is now 100% vapor. In other words, it has reached the 100% saturation point of the vapor. The saturated vapor is still at 5 degrees Celsius and still able to absorb more heat from the 24 degrees Celsius room air. At point 6, the pure vapor that now exists is normally superheated about 6 degrees Celsius above the saturation temperature. Subtract the saturated suction temperature from the actual suction line temperature, 11 degrees Celsius minus 5 degrees Celsius equals 6 degrees Celsius of superheat. At point 7, the vapor is drawn into the compressor by its pumping action, which creates a low-pressure suction. The evaporator superheat is 6 degrees Celsius, 11 degrees Celsius minus 5 degrees Celsius, and the system superheat is 12 degrees Celsius, 17 degrees Celsius minus 5 degrees Celsius. System superheat is often referred to as compressor superheat. At point 8, highly superheated gas leaves the compressor through the hot gas line on the high-pressure side of the system. This line normally is very short because the condenser is usually close to the compressor. The hot gas line has about 33 degrees Celsius, 78 degrees Celsius minus 45 degrees Celsius, of superheat that must be removed before condensing can occur. Because the line is so hot and a vapor is present, the line will give up heat readily to the surroundings. The surrounding air temperature is 34 degrees Celsius. At point 9, the superheat has been removed and the refrigerant has cooled down to the 45 degrees Celsius condensing temperature. The high pressure reading of 380.7 psig is due to the refrigerant condensing at 45 degrees Celsius. In fact, 380.7 psig is the vapor pressure that the vapor is exerting on the liquid while it is condensing. At point 10, the conditions for condensing are determined by the efficiency of the condenser. In this example we use a high efficiency, CTOA, equals 11 degrees Celsius condenser, which has a condensing temperature about 11 degrees Celsius higher than the surrounding air used to absorb heat from the condenser. At point 11. The refrigerant is now 100% liquid at the saturated temperature of 45 degrees Fahrenheit. As the liquid continues along the coil, the air continues to cool the liquid to below the actual condensing temperature. Any liquid at a temperature below the condensing temperature of 45 degrees Celsius is called subcooled liquid. In this example, the liquid is cooled to 39 degrees Celsius before it reaches the metering device. The liquid now has 6 degrees Celsius, 45 degrees Celsius minus 39 degrees Celsius of subcooling.
So, check natin dito sa sa pH diagram niya. pH diagram. Pasok! Input tayo ng lagyan natin ng Colgate. Evaporating temperature is, ilan ba yun? 5. Condensing temperature is 45. Isentropic efficiency 17. Drawing natin! Uy, wala pala akong superheat. Wala pala tayong superheat. Edit natin. I-edit. Maglagay tayo yung superheat natin is 12. Subcooling is 6. Sabihin natin points. Nine. So, sakya. Ayan na siya, mga kaibigan. Pasok! So, i-summarize natin dito. Ito yung meron tayo. Check natin. Check natin yung properties. So, meron tayong QE 174. 174.6 QC. Ito yung 207.3. COP 5 ang taas, oh. Pressure ratio 3.2. Yung work niya ay 32.6 kilojoule per kilogram. Mag-example tayo na din natin kung 1 TR. Pag 1 TR is equal to 3.5 kilowatts. 3.5 kilowatts, 1 TR. Okay, update. So, meron pala tayong QE na 1 TR. Ito yung cooling capacity niya. 3.5. Sa condenser, heat rejected niya ay 4.15 kilowatts. Mass flow rate niya ay 0.02 kilogram per second. Volume flow rate niya ay 4.86 cubic meter per hour. Ito yung work niya ay 0.65 kilowatts. Ito yung work na to. Ito yung sinasabi nila na yung pag bumili ka. Pag bilan ako ng aircon, 1 HP. Ito yon 1 HP. Kasi may ano pa yan, may overall efficiency. So, aabot ng ano to, 1 HP. 1 HP. Pero ang cooling capacity niya ay 1 TR or 3.5 kilowatts. Kaya pag bumili ka, o pag bilan ako ng 1 HP, hindi niya yung capacity. Yan yung compressor work or motor work. Yung sa motor work, kung yung sa motor kilowatts, power ng motor mo in kilowatts ay nasa 1 HP na yan kasi may efficiency pa yan. Overall efficiency ang tawag doon. So, work ng fluid ng compressor So, may efficiency ka. Overall efficiency sa mga nasa 1 HP yung ano, 1 HP yung motor. Kaya yan tinatawag nila na 1 HP, 2 HP. Hindi yun capacity. Yun ay motor ratings. Ang ano niya talaga, ang capacity niya, cooling capacity ay 1 TR, work mo ay 1 HP. Kaya hindi equal yung ano, 1 TR is equivalent to 1 HP. Hindi yun, mali yun. Kaya 1 HP, naulit ko 1 HP sa motor yan. Yung 1 TR cooling capacity niya. So, that's it. That's it, pansit. That's it, pansit. Tingnan natin yung coordinate points niya pala. Okay, babush.